Okay guys, so today we are going to talk about a little bit more about hope bifurcation. But today we will consider a different example. Hope bifurcation. Okay, hope half bifurcation. Okay, we will consider x dot is actually minus y plus x alpha plus x square plus y square, and y dot is actually x plus y alpha plus x square plus y square. So to convert this into polar coordinate, we will assume that let r square is actually x square plus y square, and theta is tan inverse y divides x, and this will give us r dot is actually r alpha plus r square, and theta dot is actually 1. Okay, so surely if okay, so if alpha is actually 0, we do not have limit cycle. Okay, and also r is actually square root of minus alpha. Alpha is lesser or equal to 0 is our limit cycle. Okay, so alpha is lesser than 0 is a limit cycle, but we will see is it stable or unstable limit cycle. Okay, so if we see, we can see that. Okay, so suppose, okay, so if alpha is actually 0, we can see that r is equal to 0 is unstable. Okay, so this means that if we start really close to 0, we will move away from 0. Okay, and also, okay, also if we see alpha is greater than 0, we will see the linear part of this r dot. So if alpha is greater than 0, surely again we have unstable. Okay, so unstable solution. And so if alpha is equal to 0 and alpha is positive, we have this, the similar kind of scenario. Why? Because it is unstable and the solution will move away from the origin. Okay, but now the real case is, what if we have r is equal to when r is equal to square root of minus alpha. Okay, alpha is lesser than 0, then what happens? So clearly f r alpha is actually r alpha plus r square. So f of r is nothing but r plus 3r square. So this means that f of r square root of minus alpha is what? So this is sorry, it is alpha. Okay, so this is alpha and plus 3 minus alpha, which is minus 2 alpha, which is positive since alpha is lesser than 0. So r is equal to is unstable limit cycle. Okay, this means that so suppose this is my unstable limit cycle, r is equal to square root of minus alpha. We know that in polar coordinates this represents circle. Okay, so it means it is unstable. It means if we start, okay, very close to the boundary from outside, we will move away from it. Okay, we will move away from it, you can see it. Okay, and if we start really close to the boundary from inside, we will start, so we will move away from the boundary. Okay, we will move away from the border. Okay, so this, and because the theta dot is equal to 1, so our direction is anti-clockwise. So this when alpha is lesser than 0. But now what about the bifurcation diagram? Okay, so now bifurcation diagram. Okay, so definitely we will look at this equation alpha plus r square. Okay, so now bifurcation diagram, what is bifurcation diagram? Okay, so the limit cycle was r is equal to square root of minus alpha, alpha is lesser than 0 is unstable, right? Unstable. So unstable means, okay, unstable means this is my alpha. Okay, so it alpha is lesser than 0, this is thing, so this was unstable. Okay, r is equal to square root of minus alpha. So because it is unstable, so that's why I represent it with the dashed line. But on alpha axis, okay, so on alpha axis what is 0? R is 0. Okay, so r is 0 means the non-linear part of this is 0. Okay, so if alpha is lesser than 0, okay, this means that the non-linear on alpha axis r is 0, this means that the non-linear part of this equation is 0. So if alpha is lesser than 0, r is positive, this means that it is stable. Okay, so this is stable. Okay, so r is equal to 0 is stable. Okay, for alpha is lesser than 0. Now on alpha axis r is also 0. On the positive alpha axis r is also 0, but the non-linear part of that is 0. So if alpha is positive, alpha r will become unstable. So unstable means we will represent it by dash line. Okay, so this where r is equal to 0 is unstable. Okay, for alpha is greater than 0. So that's what a complete bifurcation diagram in this case. Okay, I hope you understand, and thank you.